Hello. Today I discuss about the establishment of kinetic energy. Let's see how we can establish kinetic energy formula. Let's see. Here we can establish in two ways. First way, in classical mechanics. So in this way, we can establish kinetic energy. So let's see. First, we can take. We know that this establishment, the initial velocity is u and the final velocity is v, and the acceleration due to the change of velocity is a, and the displacement between this change in the velocity is. Then we will get v square is equal to u square. Here a is the acceleration. Retardation actually we have taken. It will be plus actually, not we have taken it is a acceleration, not retardation. So we'll get as is equal to v square minus u square by 2. So a is the acceleration, u is the initial velocity, v is the final velocity. So here we know that kinetic energy formula or the work done to change the velocity from u to v is the total energy or the work done is equal to the applied force multiplied the displacement. So this will be equal to m is or m is equal to v square minus e square by 2 by replacing this. So you'll get half m v square minus e square. So you know that E energy must be greater than equal to 0. So we finally can write down E equal to half m v square. So by this condition that kinetic energy must be greater than equal to 0. This is a one establishment, and from the special theory of relativity we can write down that kinetic energy is equal to mc square by root over 1 minus v square by c square minus mc square. So here we will write down mc square 1 minus v square by c square to the power minus half. In this way you can write down this square minus mc square. So this can be expanded through binomial theorem. We can write down mc square is equal to 1 mc square under bracket 1 plus v square by 2c square plus 1 3 1 3 2 2 by the formula of the binomial expansion 1 minus x to the power minus n. If we use this formula, then we'll get this minus mc square. So we'll at last we'll get this, which is nearly equivalent to half m v square. So in this way we can establish the kinetic theory. We can establish kinetic energy of any particle. Now this is this is the mass of a photon. How we can calculate a mass of photon? So mass of a photon. So mass of a photon we can calculate in this way. Here by Planck's equation we know that E is equal to h nu, where E is the energy of a photon, h is Planck's constant, and nu is the frequency of photon. Now kinetic energy of a photon of mass m is equal to E is equal to half m c square, which implies that half m c square is equal to h nu by this equation. So half m c square is equal to h c by lambda by the relation v is equal to c lambda. Nu is equal to c c is equal to nu lambda for the velocity. C is the velocity of light, so c is equal to nu multiply lambda. Nu is the frequency of light and lambda is the wavelength of the photon. So here we will get m is equal to 2h by c lambda. Now the rest mass of a photon is the 0, since we know that m is equal to m0 root over 1 minus v square by c square, where m0 is the rest mass of a photon. And if photon travels with the speed of light, you have v is equal to c. So here, if v is equal to c and the photon travels with light, then m0 must be equal to 0, since this will be equal to this is equal to 0. This portion must be equal to 0. So when photon travels with the speed of light c, then this term needs to be 0, and which reflects through the relativity that m0 must be 0. So here therefore m is equal to 2h by c lambda, and if we put the mass of the photon is equal to 6.6262 multiplied 10 to the minus 34 joules second, c is equal to 3 into 10 to the 8 meter per second square, lambda is equal to c by nu is equal to 4 into 10 to the 8 10 to the 14 to 8 multiplied 10 to the 14 hertz. Then we will get the mass of the photon 5.89 into 10 to the minus 36 kg, or nearly from the range 1.178 into 10 to the minus 35 kg. So this is the range we will get for the mass of the photon. Here we have taken the velocity of the light of the photon when it travels with the speed of light, then we will get v is equal to c. So this term vanishes. and here we have written write down here it will be actually in this form. I've written here wrong m multiply root over multiply 1 minus v square by c square. Actually, here we will get rest mass is equal to 0 by simplifying this. So here the rest mass is equal to 0.